Today I'm gonna take you in a quick kids to kids review, like by kids for kids review about the first image released by the James Webb Space Telescope. So I'm gonna show you what these strange things with lines are, how mind-blowingly zoomed in this actually is, what's going on with these strange curves, and what's this thing here? Okay, so first, the most eye-catching things about this picture. First thing you instantly notice, this star. Where'd it go? This star. This star, finally. So, this is a star, as you can see with these lines. If you see these lines, then it's a star. So, star somewhere up here. Star. A few more stars around here. But aside from that, everything else, even these really tiny dots, see here there are a few small dots, are galaxies, all of them. But this galaxy looks like the Milky Way. So what else I saw? Like, first thing I saw, second thing I saw was this. So what I mean by this is, here you see a dust cloud starting from somewhere around here, up, this dust. And then here, this is either the center of the dust cloud or a galaxy, maybe both. Another galaxy, then the dust cloud continues and ends somewhere here. So the next thing is, why are some of these galaxies? So yeah, well, that does not look like a normal sphere. That looks like a line. And what's this? That's just so curved. So why is it curved? For that, I have to explain gravitational lensing. So gravitational lensing is when, if you have, like, say this is a galaxy and all, and then light is starting from maybe this star here, say, light's going, or something like this. Then there's something either really heavy or really dense, so that's this. So the light goes, and because of this is gravity, then this is an exaggeration. Then the light goes like this and curves. For example, right here might curve like that. And if this was really dense, like a black hole, light would curve like that and eventually go in. So the thing with gravitational lensing is, these galaxies here, see all these curved galaxies which seem to be curving around this? Yeah, they are. That's because these galaxies are most probably behind this big cluster, and the light went and curved around it, sort of. So the light was coming like this and curved around. I can't show because this is not a 3D model. And then curves, so you get this. And maybe it's even the same galaxy in different locations. That can happen because some photons of light, imagine again it's like this and the light's coming from here. Some photons of light will go like this. Some photons of light will go straight. Some photons of light will go like orbitally. And some photons of light will just go. So they would be bent in different ways, and that makes it arrive at the James Webb from different angles, which is why you can probably, I can't see, in some spots, see galaxies which are repeated. And next thing, why are some of these galaxies so red? And that looks like fire. Honestly, it's like orange red. So that's because of redshift. So these red galaxies are quite far away because as the universe is expanding, galaxies which are farther away, then they're moving away from us far faster. So they're being redshifted, kind of like if you're standing on a road, or next to the road, like on the pedestrian path, and then an ambulance comes, it's gonna go wee wee, like higher and higher, higher as it gets closer. Then when it gets farther, it's gonna go like it's gonna get lower the sound because it's getting farther and the sound wave is like getting stretched. The same thing here, but with light. And much bigger speeds than 35 kilometers an hour or 20 miles an hour, much bigger speeds than that. So, but then why are these blue? If everything is moving away, then doesn't that mean that these should also be red? True. But this is not the real color of all these things. This is not actually yellowish white. This is not actually blue. Well, maybe it is, but we can't say that for sure just because it is in the image. Because the James Webb is an infrared telescope. Basically, that means, so you know the electromagnetic spectrum? I'm just going to explain it now anyways. So electromagnetic spectrum is all the different kinds of light, kinds we can see and kinds we can't. So visible light, we can see that. Then there's ultraviolet light, that's the kind that gives you sunburns. Then there's also infrared light, which is essentially heat at lower temperatures. So I'm not going to go into the details of infrared, but the James Webb is an infrared telescope from what I know. And yeah, basically these are in infrared and we can't see infrared. If we could, we would basically have heat vision. So yeah. Anyways, next thing. Well, so yeah, these are false color. Yeah, that's what I was saying. So this might in reality be, I don't know, a red star. I don't think you can see that. So this might actually be a blue star which emits a lot of far infrared. So far infrared would look reddish. And then near infrared, which is closer to visible light, would look like this sort of bluish. And this sort of bluish or violet, not this, this sort of bluish or violet might even be like the dark red parts of visible light. So we might even be able to like see the same thing as seeing. Yeah, anyways, so moving on to the next thing. This. What is this? So this galaxy, if we zoom in, the zoom in tool does not work at all. So this galaxy, if we zoom in, looks like a normal galaxy. This part of it looks like a normal galaxy, kind of like this one here. It looks like that. This part, not those two arms on the outside, looks kind of like this. So this inside part. And then it looks like two arms have extended. So imagine here we've got this galaxy or this galaxy. Imagine an arm going like that and a second arm going like that. So that's basically what this is. And for comparison, the Hubble version of this looks like, oh wait, I don't know where that is. So this is the same area of space as Hubble took a photo of, and well, you can find that out for yourself what that looks like, but I can assure you, honestly, it is just so less clear. It's like you can see this star, I think, and this galaxy, and this star, and this star, and maybe this star. That's it. You can't see anything else. Only the very bright parts are actually shown. So many people are saying that there will be 3 eras of astronomy. Before telescopes, and after that there will be before James Webb, And then there'll be after James Webb. I think this might be a bit optimistic, but it's still very cool. So yeah, I guess that's it. That's all I can tell you about this image. You can research more, look at the Hubble image if you want to. And yeah, that's it. See you.